Up till now we have discussed this equation that r1 d upon di1 of i1 square plus r2 d by di1 of I minus I1 whole square. But we have a condition that d by dx of x raised to n is equals to n x raised to n minus 1 into dx by dx. We are going to follow this condition for this. I1 square is there, that's why it is going to be 2i1 d by di of I1 plus r2. Here it is I minus I1 whole square, that's why 2 times I minus I1 multiplied by d by di1 of I minus I2, and that is equals to 0. D by d I1 of I1 is going to be 1, that's why that equation will be 2r1 I1 plus 2 r2 I minus I1, and then differentiation of I, so d by di1 of I minus di1 by di1, d by di1 is equals to 0 and di1 by di1, that is 1. So we can say that 2r1 I1 plus 2r2 I minus I1, and it is 0 minus 1 is equals to 0. So we guys can say that 2r1 I1 minus of 2r2 I minus I1, that is equals to 0, and that's why 2r1 I1 minus 2r2 I plus 2r2 I1 is equals to 0. Now if we are simplifying this equation, we are going to have that r1 I1 plus r2 I1, that is equals to I r2, and that is equals to I r1 plus r2, that is equals to I r2, and that's why I1 will be equal to I r2 upon r1 plus r2. But we also have to evaluate the value of I2. So for that we can say that uh, I2 is equals to I minus of I1. So I1 has a value of I r2 upon r1 plus r2, and if we are simplifying that equation, we are going to get the equation that I2 is equals to I r1 upon r1 plus r2.